Hello, my name is Rachon. I'm a section leader of Brewing Microbiology Research team here at Camden BRI, and today I would like to talk to you about our service into pasteurization optimization of beverages. Few key facts that I want to mention before I start talking about this is about pasteurization. Pasteurization is one of the essential processes that can help us stabilize not microbiologically stable beverages. The main objective of pasteurization is to kill vegetative bacteria and yeast and extend shelf life of this product. Pasteurization will not kill mold spores or will not kill spores of bacteria. Are those much more heat resistant, and they would require much higher temperatures. Some beverages may not need pasteurization at all. They would be microbiologically stable, so it's very important to check this as well if you're thinking that you should be doing pasteurization. Products which I have in mind are products that may have high alcohol content and low pH, for example, cocktails. But for those which need pasteurization, it's essential to know what exactly pasteurization, what level of pasteurization is required, because if we're not going to know this, we very tend to end up over-pasteurizing this product. Currently, brewing industry and drink industry is very creative, and we develop lots of very interesting products, very unusual products. We're working, as you know, with non-alcoholic beers, non-alcoholic ciders, non-alcoholic wines. We doing lots of development with cocktails, with beer wine mixes, with other fermented beverages such as kombucha, water kefir, or some functional drinks. And all those, very often those will require pasteurization, but because those are new products, we don't know exactly what pasteurization is required. So normal approach for attacking this would be to look for the most heat-resistant microorganism which can spoil those products, and then trying to find out how to kill this. But very often this may take us a time, and this can be very expensive. So we wanted to start with finding microorganisms that we can use for kind of any kind of product that would give us certainty that if we kill this microorganism, we know that we kill anything else that can spoil those products. And we spent few years into this, looking for this kind of microorganisms, and we find out that this microorganism is yeast ascospores. Ascospores can be produced by yeast, and this is kind of similar like mechanism of is similar like bacterial spores. This is like typical mechanism, defense mechanism for population to survive. And ascospores would be more resistant than yeast, but also they are more resistant than spoilage microorganisms, which is really good news, because if we use them, if we kill them in the process, we know that everything else is being inactivated. So our service is starting with measuring decimal reduction time, D values and Z values of this yeast ascospores, which we call pasteurization bioindicator. And once we have those values, we can calculate what kind of temperature and time is required to eliminate 6 log reduction of this microorganism from the process. And when we do this, if we do this, we know that everything else is inactivated. When we determination of D and Z values is normally performed in the capillary test tubes, so it takes us some time, but give us a precise answer to how to kill this microorganism in the product. And then we would also wanted to verify if this is still applicable in the product when the product is packaged in the original packaging, in the bottles or in the cans. And so we would use this micro, instead of ascospores, we would inoculate cans and bottles, and we would place them in the pasteurizer, and we would run pasteurization, which we calculated parameters for this product, and we would verify is those results still valid for pasteurizing of this product. Thank you very much for attention, and if you would like to know more information about this service or details or how we can help you, please get in touch with me directly or with anybody at customer services here at Camden BRI. Thank you.